Assalamu alaikum, everyone. Welcome to Mathematics with Shahab Yaqub. So finally, the chapter, the most fearsome chapter, that is mensuration. That's right over here. And mensuration, there are two aspects of mensuration. The first one is 2D mensuration. The second one is 3D mensuration. Now, let's first go through the syllabus of mensuration. So mensuration is unit number 5. We should be well aware of the units of mass, length, area, volume, and capacity. That's another name for volume. And what else is there in practical situation, and convert quantities into larger or smaller units. What are the units that we are talking about? Millimeters, centimeters, meters, kilometers, millimeter square, centimeter square, meter square, kilometer square, millimeter cube, centimeter cube, meter cube. There is no kilometer cube. Milliliter and liter, gram and kg. Conversion between units include centimeter to meter square and vice versa, meter cube to liters and vice versa. So that's the first thing. Now the second thing, area and perimeter. Carry out calculations involving the perimeter and area of a rectangle, triangle, parallelogram, and trapezium. Except for the area of triangle, formulas are not given. What does it mean? That means the area of triangle, this is given. And for rectangle, for parallelogram, for trapezium, the formulas are not given. Formulas are not given. What else is there? We talk about circles, arc, and sector. And naturally for perimeter, that's also not given. So formulas are not given for these, whether it's about perimeter or whether it's about what you call area. Circle, arcs, and sectors. Carry out calculations involving the circumference and area of a circle. Answers may be asked for in terms of pi. Now, this is something that I like very much. That is working in terms of pi. So in terms of pi, I'll put a lot of emphasis on this. So lot of emphasis on this thing, working in terms of pi. And someone is saying they cannot hear my audio. I think better, it's all good. Let me just double check. Others, do you confirm? Is the audio audible? Yes. Better, then someone has their own issue. So let me continue. So now I would be working a lot in terms of pi, and then in the end, I'd be doing the conversion. So this is something I need to teach you very much. And then it says, carry out calculations involving arc length and sector area as fractions of the circumference and area of a circle. That is a beautiful way of writing about the syllabus, especially these formulas. They are fraction of circumference. Arc length is a fraction of circumference, and sector area is a fraction of the area of a circle. And then we are talking about surface area and volume. Carry out calculations and solve problems involving the surface area and volume of a cuboid. That includes cube also. Prism, cylinder, sphere, pyramid, cone. And what is given in notes and example? Answers may be asked in terms of pi. That's perfectly good for us. Curved surface area of a cylinder. And then curved surface area of a cone. Surface area of a sphere, because the whole sphere is a curve, so that's why they do not write it as curved. Volume of a prism, volume of a pyramid, volume of a cylinder, volume of a cone, volume of a sphere. We will go through every single formula that we will use. The term prism refers to any solid with a uniform cross-section, that is a cylindrical sector. So now, technically, for some people, they do not consider cylinder to be a prism. Why? Because the edges are not straight. But for our purposes, we consider all these to be a prism. A cuboid is a prism. A cylinder is a prism. A cone is not a prism. So as long as the cross-sectional area is constant, as long as the cross-sectional area is constant and it's standing or lying down, it would be considered a prism. And then it's a combination. What kind of combination is this? Compound shapes and parts of shape. Carry out calculations and solve problems involving perimeters and areas of compound shapes, parts of shape. Carry out calculations and solve problems involving surface area and volume of compound solids, parts of solids. So that's a combination of all these things. Answer may be asked in terms of pi. Find the surface area and volume of a frustum. Now, what's a frustum? We will soon see. Now, first of all, there are questions of 2023 and 2024 in this particular PDF. But first of all, let me go to the working that I've done over the years. And let's start from the very basic. So there is no hurry. We will start from the very, very basic. This is about 2D mensuration, circle, arcs, and sectors. First of all, the terminology. A circle, if I draw a chord is a line that joins 2 points on the circumference of the circle. A diameter is technically a chord which passes through the center. That is the largest chord in any circle. So that is the largest chord in any circle. So right now we are talking about a chord such as this, AB, and it divides the circle into 2 halves. So let me just grab my eraser over here and let me just remove these things so that it appears a little bit neater. Okay, so now it divides the circle into 2 parts. The small is called minor, the big is called major, and this is like a segment. Part of the circle, this is minor segment, that's major segment. Now over here, this is the chord AB, and this part of circumference, that is the arc length AB or arc AB, and the length of this arc is called the arc length. Now from the center, I have drawn a line to the circumference, another line to the circumference. This is called radius. So now what you created over here, that pizza slice, this pizza slice, this whole thing is a sector. So if I take out this segment between the chord and the circumference, that's a segment. This is a triangle. So triangle plus segment is sector. That means if I have the sector area formula, if I have the triangle area formula, I can do subtraction. And what can I find? I can find the area of the segment. Now, the first acknowledgement that I need from you is that segment and triangle and then sector. This relationship is this all good, all clear. That is the first thing. And then, yes, there is also about perimeter. What about the perimeter? The perimeter of the sector, perimeter means like you are walking from here, that is walking along the boundary. The length of all these edges, that is the perimeter, that is R plus S. And soon we will write down the formula for S. Now, if I take a circle and if I divide it into 4 equal halves, all the areas would be equal. So this is called a quarter circle. And if I divide it into 2 halves, that is called a semicircle. So basically, depends on the angle, that's how it's being divided. So this is the ratio that was talked about in the syllabus. So this ratio of theta to 360 degrees, this is the angle theta to 360 degrees into the circumference formula, that will give you arc length. So arc length is ratio of theta to 360 of 2 pi r. Similarly, theta is to 360 of the area of a circle, that will give me area of sector. So over here, this thing 1/4. How do you think this 1/4 came along for a quarter circle? So 90 is to 360. That is for quarter circle. That is this 1/4. And for that's also for area. Arc length of quarter circle, that's 1/4 circumference. Area of quarter, 1/4 area of circle. If, for example, I was talking about a semicircle, so area of semi, it's half pi r square. How do you think this came along? This came along this way, that if I draw, it's not a nice arc, something like this. If I draw an arc like this, just ignore the shape. And if this angle is 180 degrees, so therefore area of semi, that is 180 degrees divided by 360 degrees into pi r square. That's how you get the area of a semicircle. All good, all clear? Trigonometry, we just studied before, so I don't need to emphasize on it. Let's take a simple example. The length, arc, and perimeter. Let's say there is a chord AB. The diameter is 10. The angle over here is 60 degrees. A simple basic example from my side. And let's say I want to find what is AB. So I have two sides, included angle. I can find AB. It's coming out to be 10. Now, technically, I don't need to use this. Why? Because if an isosceles triangle is here and this is 60 degrees, isn't these two also 60, 60? Because these two are equal because of isosceles. This thing is 60. So theta plus 60 is 180. Theta is 60. So this isosceles actually becomes what? An equilateral triangle. So if this is 10, this is 10. Naturally, this is also 10. Now, this thing over here, arc length AB, theta over 360 into 2 pi r, 60 over 360 into 2 pi into 10. I am working in terms of pi. Now, work in terms of pi till the very end, then plug in the value so that your accuracy is maintained. Now, over here, perimeter, that would be this radius plus this arc length, that would be the perimeter. So r plus this is 10 pi by 3 from here. That is the perimeter in terms of pi. And let's say if someone wants this answer in decimals, so I'll convert it by plugging in the value of pi. So let me write something over here, a statement that I'm interested in. Let me add this thing over here. Yes. So now a points to ponder, that is use value of pi as 3.142 because this is already 4 significant figures. And the next point is work in terms of pi till the very end and then plug in value of pi. All good, all clear? So that is some instruction from my side in order to preserve accuracy. So preserve accuracy. That is what we are focusing on because we don't want to lose marks just for no reason. So that is what we will follow. So let me just take a screenshot. And let me share it with you. So I'll just share it after a while. Okay, so now this thing is there. Now major arc length. Now if I need this arc length, there are two options. Option 1, find the area, find the whole circumference, and then subtract the minus sector. So you will get the arc length. That's one thing. Or use this angle. That is 300 degrees and then the same formula. So major arc length, use the reflex angle, that is 300 over 360 into 2 pi r. Again, I left the answer in terms of pi. Or circumference of circle minus arc length minor will give you major arc length. Both working is there. Now, what about this? One more thing. All these videos I recently uploaded maybe like 4 months ago or something like that. So do check out on the YouTube channel. All these videos are there, the one that I'm talking about. So I'm just going over the basics. Area of triangle OAB. Area of triangle OAB, that's half AB sine C. That's half AB sine C, AB sine of 60 degrees. Make sure your calculator is in the degree mode. And you can ask some of these things also to me when you'll be coming for the workshop. So therefore, this answer is 25 root 3 centimeters squared. Area of sector, what's the formula? Theta over 360 into pi r square, that is 50 pi over 3. Therefore, area of sector plus area of triangle. Area of sector is the triangle plus the segment. In this question, area of segment is area of sector minus area of triangle. So this is called writing answer in exact form, which means in O levels in terms of pi and in surd form. So sometimes, since surds are very much now part of syllabus, so examiner can ask you to leave answer in terms of pi, to leave answer in surd form, that is the exact form. As soon as you apply the use of calculator, that won't be exact because you have to round off to a certain level of accuracy. So now, first of all, the elaborate, what you call example. Let me write it down, the elaborate example, and then this thing, exact form. These two things, is this all good, all clear? Now, let me show you some of the working from here. I think it's, let me just go over the thing first. There are some paper 1 questions and then some paper 2 questions. Let's look at this question. It says, let me first copy this so that you are not confused by the working, and then I'll show you the working. Let me just draw a thick line over here. Go through the question, I'll solve it. It says OAB is a sector of a circle. Let me just check one thing that I always have the doubt of. The recording is all good, all clear. OAB is a sector of a circle with center O and radius 8 centimeter. AOB is x degrees. AOB is x degrees. Write down an expression in terms of x. So now the angle is not theta, it's x. Pi for the area of sector OAB. So first of all, area of sector OAB, that's how you write it. That is x degrees divided by 360 degrees into 2 into pi into r. Instead of r, write 8. Because this 8 is given over here. So therefore, this can be written as 16 over 360 degrees into pi and x. I can write it like this. And then I can do a bit of cancellation. So 4 fours are 16, 4 into 90, and then 2 is to 45. So this comes out to be 2 over 45 pi x degrees. That is the area in terms of pi and x. And constants naturally will be there. Then it says, that's one thing. Thank you. This, I forgot to square it. Someone pointed it out. That's good. So people are alert. So now this is 2. This is the area. My bad. I use the formula for this thing into pi into x square. So therefore, this is 8 square. So therefore, this is x degrees, this is 360 degrees, this is pi, this is 64. Now divide. 4 into 16, 4 into 90. And then we can do one more. 4 fours are. And actually, let me make it 2. This is 8, this is 45. So this is 8 over 45, and then this is pi in x. So this is pi in x, and that's the answer for this one. The next one, PQR, part B. PQR is a semicircle of radius 4. The area of sector OAB, that's given over here, is 1/3 area of semicircle. So area of sector OAB, which is the small one, is 1/3 area of the semicircle. So first of all, let me write over here semicircle separately. That is half of pi into 4 square. Now keep in mind, this is the radius 4. The whole thing is 8. We just need this 4. So pi into r squared divided by 2, that is area of semicircle. That is half of pi into 16. That comes out to be 8 pi centimeters square. And then write the statement. That is this thing, area of sector OAB. So area of sector OAB is 1/3 area of semi. This one is what? 8 over 45 pi x degrees. 8 over 45 pi x degrees is 1/3. That is 8 pi. So now do the cancellation. This is 8, this is pi, this is 8, this is pi. That's gone. So x degrees is 1/3 of 45 degrees. Therefore, x degrees is 15 degrees. So this is paper 1 question without the calculator, no issue. So now this is paper 1 conceptual question. I think it's all good, all clear. So I think that's enough of arcs and sectors, and naturally rest you can watch in that video on YouTube, and do write some comments over there, whether how much you found it useful. So now the second thing, that is some extra spacing. Now let's also talk about 2D mensuration, quadrilaterals, 4-sided figures. I think I forgot to do some questions, so maybe they are part of the other thing. So let's talk about this. Now let me get started with cubes. So let me just add this thing, erase this thing, and this thing. Now let's talk about cubes and cuboids. So this Rubik cube, that is a cube, because it's a prism in 3 dimension. Prism is in 3 dimension, and the cross section is the same. Now I'm talking about cube right now. So now cube and cuboid, there are 6 faces or 6 sides. All of these are of equal length. Area of each face, that is x into x, because it's a square. That is x squared. Solid cube, total surface area, TSA, that is 6 times this, because all the faces are there. Volume, that is length into width into height. Width is also known as breadth. So width, this is height, this is length. So length into width into height, let me write it down. That is length into width into height, since all these 3 are the same. So that is the formula. Solid cube, total surface area is this, volume is this. What if the top is missing? Open cubical box. So let me just pick this thing up and write it over here. It's an open cubical box. Now there are how many sides? There are 5 sides. So the total surface area is 5 times x squared. The volume is unchanged. So here is the comparison between the two. Solid or closed cube, volume is the same as an open one. Total surface area, this is 6x squared. One of the faces missing, it's 5x squared. Square in 3 dimension, that's a cube. So now let's talk about cuboid. So if I talk about cuboid, it's a rectangle in 3 dimensions. So this is the length, this is the width, this is the height. So this one is the base, this is floor, that is the ceiling. This is the right hand wall. This is the left hand wall. And this face over here that I am focusing on, that is the front wall. And if I focus on this one, that is the back wall. Got the idea? So let's say you are in a rectangular room. Solid, cuboid, rectangle in 3 dimensions, that's written. Solid, cuboid, closed rectangular box, total surface area. That's length into width. That's the area of the floor. That's the area of the ceiling. Width into height. That is the right-hand wall. That is the left-hand wall. Front and back. That is length into height. That is length into height. So this is 2 of each. The front and back are the same. The right and the left are the same. The top and bottom are the same. That is what I've explained. So total surface area is all these things. Now, if it's an open rectangular box, so I think I wrote too many things in one place. Let me just take this down. So first of all, let me stop over here and let me focus over here, not this thing. So now if it's an open rectangular box, so the top is missing and there are 2 of this thing, there are 2 of this thing and 1 of this thing. So this is the floor. The ceiling is missing. The top is missing. The ceiling is missing. So 2 of the walls, 2 of the front and the back, and 1 of the floor, the top is missing. What about the volume? The volume of the cuboid, that is length into width into height. That's length into width into height. And that is the comparison between the 2. The volume is the same, that's unchanged. And the total surface area and this thing are different. So now let me share some images with you. Let me pause the recording. And I would like you to copy this down first. So now, once you have noted down the formulas and everything, so let's move on. This bio thing is coming up. So now over here, this is all talked about. Let's pick up few questions, something like this. So now this is paper 1-2 again. It says a container is made out of thin metal. That means we ignore the thickness. That's what it means. In the shape of a cuboid with an open top. So let me just copy this first. Let me paste it over here. And then let me just highlight it like this. And then it says it's made in the shape of a cuboid with an open top. The container has a length of 15 centimeter. That's right over here. And a width of 8 centimeter. The volume of the container is 720. Calculate the height h of the container. Pretty basic. Calculate the surface area of the outside of the container. Good question. Now, first of all, let's talk about this. When we talk about the outside, that means only one side of the wall is taken into consideration. So 15 into h, and over here 15 into h, over here 8 into h, over here 8 into h. And what about the base area? What about the floor? That is 15 into 8. Now, how can we find h? We can say that 15 into 8 into h equals to 720. And then we find the value of h. And then it says liquid is poured into this container. The liquid fills 60% of the container. Calculate the height of the liquid. That means whatever is the value of h, just take 60% of h. Why? Because let's say if it's 50%, that means the height of the container should be half, because we are not changing the other 2 dimensions. So what is changing? The height. If it's filled to half the level, that means it's half full. It's filled to 60% of the level, so the height should be 60% of this value. Now let's look at the working. 720, 15 into 8 into h comes out to be 6. And paint, bucket, and brush. That's how you think about surface area. You have a bucket full of paint, and I have given you a brush, and I ask you that go and paint on the outside. So whatever area that you paint, that is the surface area. That's 15 into 6, that is the height. So 15 into 6, that is this thing, the front and back. And 8 into 6, that's 8 into 6, that's right and left. And 15 into 8, it's only once, that's the floor. And 60% of each, 60% of 6, that comes out to be 3.6. That's a basic kind of a question. A question such as this. Yes. Let's look at this question. And hold for a second. Let me just check one thing. Yes, the voice is on. The recording is on. Where is it? Okay. So now someone is asking few questions. Let me just go to the WhatsApp. So why is the outside highlighted as we have used the usual formula? Because they're asking for the outside area. If they ask for the inside area, I have to double each side. That is why. And I think that is about the question. Now it says a rectangular block of wood has dimensions 24, 9, and 7. So that is 24, and then 9, and then 7. It is cut up into children's brick. So that is the children brick, 3 by 3 by 3. Each brick is a cube of side 3 centimeter. Find the largest number of bricks that can be cut from the block. Now think about it. This is not your usual formula that you evaluate the volume of this. You evaluate the volume of this and then you divide. No, it's not like that. It is something like more conceptual. So now what you do is that 24, if I'm talking about this, so 1, 2, 3, 4, 5, 6, 7, 8, 8 blocks could be cut this way because 24 is properly divided, fully divided by 3. So 8 blocks, like a 3 and a 3 and a 3 like that. Similarly, if I go this way, 9 can be divided in the same manner. So therefore, 1 and 2 and 3, 9 is completely divisible by this 3 over here. But what about 7? Instead of 7, if it's a 6, so I would have said that it would be divided into 2 like this. So now 24, let me write it over here. So 24 divided by 3 into 9 divided by 3 into 6 divided by 3. So this is 8, this is 3, this is 2. 8 into 3, 24. 24 into 2, that is 48. 48 whole blocks will come out. But since this is not 6, this is 7, that means a little bit top area like this. Do you feel it? Top area like this is left out because this was not used. It was just like a 3 into 3 like this. You got the idea? The height was 3. This height was 3. So now this region is left out. What is the area of this region? That is 24 into 9 into now the small height is 1 centimeter. So this is 24 into 9 into 1. That is 20 plus 4 into 9 into 1. So therefore, this is 180. 9 4s are 36. 180 plus 36. That is 216. That is left. A very conceptual question. Let's look at the working over here. First, I modified this question. I made it into 6, just like I told you. So that's 8. Lengthwise, 8 blocks can be cut. Widthwise, 3 blocks can be cut. Height-wise, 2 blocks can be cut. So 8 into 3 into 2, that's 48. Now the original question, that's 8 into 3 into 2, remainder is 1. So how much is left? 24 into 9. That's how this thing is left. So now this block question. So I hope that's all got all clear. And remainder wood question. I hope it's all got all clear. Yes, someone also answered it correctly. And waiting a little bit. Okay. Now let's move over. Now let's talk about cylinders. So let me go to the front. That's the cylinder. And let's talk about the cylinder. So I think in today's class, we'll just be going over the formulas and the basic examples. And in the next class, we will be going over like 2023 and 2024 questions. So I think every single question is worthwhile. So now it says it's a cylinder like a soup can. A glass could be a cylinder. So now over here, diameter is 2 times radius. This much is the radius. When we talk about volume, whether it's a closed cylinder or solid cylinder, so let me write over here, whether it's closed, whether it's solid, whether it's open, that is the cross-sectional area, which is a circle multiplied by its height. That is how the formula came into being. A lot of people, they ask me this question, that how do I remember the formula? Once you understand it conceptually, formula will become easy. Any which way, the formula thing will be given this time, but still understand it conceptually. So this is area of circle into height or length. If it's standing up, that is the height. If it's lying down like this, that is the length. It's the same thing. So cylinder is a circular prism, cross-sectional area into height. Now, let's talk about a solid or closed cylinder. There is a top area. So let me focus on this. That is the top area, the red one. And then there is the bottom area. That's also circle. And then there is this thing, the curved surface area. That's going like this. So let me just make it thicker so it looks better. So this is the curved surface area like this, going all around. So the curved surface area is this thing. That is this one. And the top area is this thing. And this is, my bad, I just labeled it, mixed up the labels. Hold for a second. The curved is over here. The top is over here. The bottom is over here. So therefore, it's a circle area. It's a circle area. That's 2 pi r h. And there is also logic for 2 pi r h. That's the circumference multiplied by height. Because if I open it up, it forms like a rectangle. So that's how the formula came into being. Rectangle soup label. I think I might have opened this up. Yeah, something like this. So if I take this thing, soup label, and if I open it up, it opens up like this. So this is 2 pi r into h. That is area of rectangle, 2 pi r h. All good, all clear? So now let's move on. What if it's an open cylinder? There is nothing at the top because it's open. There is base area, which is pi r square. The curved surface area is the same. So now this is pi r square plus 2 pi r h. And that is the thing that connects the two. So closed or solid versus open. So closed or solid versus open, the volume is unchanged. That's the same, pi r square h, pi r square h. Curved surface area is over here. That is 2 pi r h. That is 2 pi r h. Base area is there. Top area is missing. Does not exist in an open cylinder. That is the total surface area that you see over here. So I hope it's all good, all clear. Let me try out some questions and let me this time ask you to try it. There is no fear. So try this out. This is a paper 2 question. Take out your calculator and try out this particular question. So let me just label it. This is a paper 2 question. And let me just show you the question and let me pause the recording. So now people, let's have a look at this question. Always, it's a good habit to underline things, and that is what I want you to do in your exam also. More details in the workshop, inshallah. So let me remove this thing and cones and cylinders. Now, first of all, what exactly are they talking about? They are talking about a closed cylindrical tin is 11 centimeter high. And the base has a diameter of 7. That's the diameter. Therefore, you should work in radius. Calculate the volume of the tin. Calculate the total external surface area of the tin. That means, let me just shade this. When we talk about the total external surface area, that means that's too thick. That means there is the base area, which is the same thing as the top area. Okay. And that's external. We are not going on the inside. Just think of that paintbrush example and then think about this. What do you call this thing? That is the curved surface area. So just apply the formula and then calculate. In addition to the surface area, a closed tin requires an extra 30 centimeter cube of metal to allow the top, bottom, and side to be joined together. That is use of welding. Calculate the area of metal required for this 30,000 closed tins. So just add this thing over here, centimeter cube, multiply with 30,000, and then convert it into square meters. So let me tell you about the working meter to centimeter. That is multiplication by 100, correct? That means 1 meter is 100 centimeter. If I want to talk about area, then 1 meter, the whole thing square, that is 100 centimeter, the whole thing square. And let's say if I want to talk about volume, then 1 meter, the whole thing cube. You don't have to remember anything. You just have to remember the concept. 100 centimeter, the whole thing cube. So it depends on what exactly do you need. For area, use this. For volume, use this. So now let's look at the solution. First of all, use pi as 3.142, 4 significant figures. Volume, that is pi into 3.5. Half of this is 3.5. Square into 11, that's the volume, round off. Calculate the total external surface area, that's 2 pi r squared, 2 pi rh. Now focus over here. What have I done? That is one thing that I want to focus over here. So let me just also open the WhatsApp group. And that's over here. That what you see on the screen is that the total surface area is 2 pi r squared plus 2 pi rh. What have I done first? I have taken 2 pi r common out. What's on the inside? R plus h. Simplify as much as possible and then insert the values. More details in the workshop. So now that thing is there. Now, what about this thing? That is the second part, the third part. What I have done is that I have added this 30 to this answer and then multiplied by 30,000. I get this large value. 100 centimeter is 1 meter square both sides because it is centimeter square. So 1, 2, 3, 4, 0 centimeter square is 1 meter square. Write it out. So basically 4 zeros are disappearing and then there are no zeros. So basically shift decimal 1, 2, 3, 4, 1046.7390. And if they are asking 3 significant figures, so that is 1050 centimeters square. Because this is first, this is second, this is third, this is the fourth one. So 1046, it lies between 1040 and 1050. Which one is it closer to? It's closer to 1050. And that's how the answer is written, correct to 3 significant figures. So I hope this is all clear. So now cubes and cuboids are done. So this is cube, this is cuboid, and that's all done. So now let me remove this thing. Now let's talk about cone. Again, these details are there also in the videos. So of course you have to watch them. And the thing about watching videos, a lot of you people consider this thing, that when you are watching a video, it's not just about watching. It's not a Netflix series. It is math. Yes, you can watch it first, understand it once, then watch, pause, stop, jot down, highlight the details, use a pencil, use a highlighter, not excessive highlighter, use a red color pen, use a purple color pen, whatever your choices, highlight the things, make boxes the way that I make boxes in order to emphasize things. Yes, this is the key point on this particular question. Let me remember this thing in full detail. That is how you score your A star. All good, all clear? So cones and frustum. Now, first of all, look at this formula. That is this thing, cones and frustum. So now we are talking about a cone. And if I look on the inside, this is the slant height. This is the height, the normal height, the perpendicular height. This is radius. So they are connected by trigonometry, right angle triangle. So this is known as all famous Pythagoras theorem. Volume, 1/3 volume of cylinder. That's how I remember it. But now you have the formula also. And let me just tell you one thing. That is getting ready to teach Cambridge O-level math syllabus day. A lot of people, they ask this question. We have added certs. Exponential growth and decay. Yes, most probably this Sunday or sometime during the next week, I'll be taking a live class on this. I have made a video on certs. I have made a video on recurring decimal. Expanding more than 2 brackets, I should be focusing a bit more on this. Finding roots graphically, that's already there, but I think I should focus a bit more. And then again, this one, let me just erase this thing. Hold for a second. Let me change the color. So exponential growth and decay, this I would work on this. Draw and interpret graph for exponential growth and decay. Yes, very, very important. What about this thing? That is composite function, the one in pink. I need to focus that. Recognizing and sketching graphs up to quadratic. This is already done. So this thing is already done. Of course, you need to watch the video. Knowing alternate segment theorem for circle, I can focus a bit more on this. So alternate segment theorem. So let me focus a bit more on this. And let me pause for Azan. So now people, let's again have a look at this one. So we were talking about what new things were added. Inshallah, I'll be going over and making videos. Either I would take a live class, that is one option, or I'll go record it on this. So any one of the option, I'll soon let you know. And then, yes, we know that it's a 2-hour paper for both, 100 mark for both, and all these things. We have introduced a formula sheet. We have introduced a formula sheet for all papers, and the formula sheet is not given over here. It's given someplace else. I'll soon share along with the specimen papers. So coming back to this thing, cones. So volume of a cone is 1/3 volume of a cylinder. So this is volume of cylinder, pi r square h multiplied with 1/3. That's the volume of a cone. Now, there is a curved surface area. That is this thing. That's the curved surface area of a cone. So if you look at this ice cream, and if you focus not on the ice cream, but on the cone, that is the curved surface area, what you hold in your hand. And of course, it also has a base area. So now over here, that's the curved surface area. And there is the circular base. It has an area pi r square. Curved surface area, the formula is pi rl. So pi into radius into length. That is over here. This is pi into length, radius into radius. And that's how you should also check the dimension. This is centimeters. This is centimeters. That is centimeter square. This is centimeter whole square. That is centimeter square. Therefore, the total surface area of a solid cone, that is pi r square plus pi rl. And what if the cone is hollow? That means the base is missing, hollow. That means the total surface area is curved surface area only, and that is the outside curved surface area, because we are not going on the inside and painting it. And that is the comparison between the two. The cone versus the cone, solid versus open. Solid is the same thing as closed. The volume is the same. The total surface area, curved surface area, both of them has it. And in the solid or closed, there is a base area also. The base area is missing. So base area is missing over here. Now, very important question. This one, I'll come back to it in a short while. Let me first talk about something of frustum. Now, I won't do this whole question. I think I haven't done it. Hold for a second. Now, first of all, let me tell you what is a frustum. So let me just copy this thing. And let me paste it over here. Now this shape over here, just focus on the shape. So this shape over here, that is the cone has been chopped. That is this thing. And over here, I can see this thing. And of course, you can also see that thing over here. And let's join it like this. This shape over here, this is a frustum. So this thing over here, this shape is a frustum. That means part of the cone has been chopped off. Now, there is no separate formula for this. If we talk about volume of frustum, that is volume of big minus volume of cylinder. Let me call big cylinder minus volume of small cylinder, which has been removed. Just subtract the two and you will find the volume of the frustum. So I'm just focusing on this thing about the frustum. Let me just grab this thing. And let me take a screenshot if it's possible. Yes, I think that's good enough. So let me also share this thing over here. And the image is saved. So now that is a frustum. So just want to focus on that. Now, this question over here, let me do one question from here. Okay, just focus on this. Why don't you go ahead, take a few minutes and try this out. Pausing the recording. So now this particular question, no, I'm not studying bio. This particular question over here, it says, let me highlight it. Volume of a cone, area of curved surface area. A solid cone has a base radius of 8 and a height of 15. That is 8. That is the height 15. If I'm interested in the slant height, so I'll use Pythagoras theorem. Once I get the slant height, I can find its curved surface area, which is what? Which is pi RL. The total surface area, that is area of curved plus area of base, very simple. And how can you find the volume? Volume is 1/3 pi r square h. That is r and that is h. And then you get this answer. So that's right over here. This is 1/3 pi r square h. I left the answer in terms of pi, and then I plugged in the value of pi. I applied Pythagoras theorem. I found the value of L. Curved surface area, that's pi r L. That is pi into 8 into 17. Total surface area, that's the base area. First add these two. That is what I have done. And then multiply with 3.142 and then round it off, correct to 3 significant figures. So I hope this is all good, all clear. So that thing is over here, which is which question? This is about cones. This is all good, all clear. So let me remove cone from here. Let me talk about, first of all, let me make it short. Let me talk about prism, sphere right now. So just the basic idea. When we talk about sphere and prism, so a circle in 3 dimensions, that is known as a sphere. There is a center, there is a radius, and this is your radius from the center till here. And then you rotate it like this. The volume of a sphere, that's 4/3 pi r cube. The surface area, 4 pi r square, 4 times the area of the circle. When you cut a sphere into half like this, what you create are spheres. And that's the most beautiful example. I hope everyone likes oranges. And that's how you cut into 2 equal halves. Now, that is the base area. If I put it flat like this, that is the base area. And this is the curved surface area. The curved surface area is half the area of sphere. The base area is pi r square. Now, if it's the curve and the base, so the total surface area of a solid hemisphere is 3 pi r square. The volume is half the volume of a sphere. That's 2/3 pi r cube because it's half of 4/3. Hollow hemisphere, the base is missing. So total surface area is 2 pi r square. And again, a comparison between the two. Sphere, volume is this. And it's solid or hollow, doesn't make a difference. Volume is unchanged. Surface area is on the outside. That's 4 pi r square. Hemisphere, solid or hollow, volume does not change. Surface area of solid, 3 pi r square, because this is 2 pi r square plus pi r square. That's what makes it 3 pi r square. Surface area of the hollow, it's only the curved surface area, that is this. And let's look at this particular question. It says the spoon is used for measuring in cookery, consists of a hemispherical bowl and a handle. So that's the handle, that's the bowl. The internal volume of the hemispherical ball is 20. The length of the handle is 5. Find the internal radius. Since they are giving us the internal volume, they have the liberty to ask the internal radius. So therefore, 2 pi r cube equals to 20. Therefore, r cube is this thing. Use a calculator and then you get this answer. The hemispherical bowl is geometrically similar, and this we will talk about in similarity. It's geometrically similar to something which has an internal volume of 50. So when we talk about a volume of similar figures, the ratio of volume is ratio of length whole cube. The ratio of area is ratio of length whole square. We will talk about it later. Right now, that was just a part for it. And then there is another part. An open hemisphere of radius 5.5 centimeter is used to make a metal kitchen strainer. 50 holes are cut out of the curved surface area. Assume that the piece of metal removed to make each hole is a circle of radius 1.5 millimeter. This is what? Centimeter. This is what? Millimeter. So I've converted into centimeters. Calculate the external surface area that remains. Radius is this thing. Area of each hole is this much. There are 50 such holes. Multiply. Insert the value of pi at the end. That's the total area of 50 holes. The curved surface area, because we are just talking about this thing, just the curved surface area. That is 2 pi r square. That's 2 pi into 5.5 square. That is this. From this, this thing is removed. So how much remains? This much. And this is correct to 3 significant figures. So we also talked about the concept of spheres. Very simple, very easy. And I'll be sharing some pictures a little bit later. So now we will talk about the pyramids in the next time. And then there is also prism. That's a beautiful example of a prism. Nets of solid. I think that is the right one. Or maybe there is another what you call PDF over here. And then we will be doing some questions from the recent year's past paper. So stay tuned for more content on Mathematics with Shahab Yaqub. Take care, everyone.